The domains of the trigonometric functions are basically based on that table that we just drew up with the border angles. So sine theta and cos theta were defined for all angles. In other words, there was no angle that made them not able to be calculated. So the domain for those is all real theta. Theta can be anything, and that explains why when we graph the sine and cos curves, you'll see they have no breaks. They go up and down, and they stretch on forever. So x can be anything. That's what we're normally used to seeing domain as equaling. But when we graph these functions, we're graphing them in terms of different angles. So theta will be on the x-axis. So when we talk about the domain, we're saying what can theta be, because that's what will be on the x-axis. Now tan theta and sec theta were undefined when x was equal to 0. So those were the ones that were straight up and straight down. 90 degrees to 70 degrees. And every time we do a lap, we'll have minus 90, 540. It goes on in both directions. So I've put dot, dot, dot and dot, dot, dot at the end there. And then cot theta and cosec theta, they were undefined when y equals 0. Those were the ones when we had our point P right out to the sides at either 0, which is 360, or 180. So that means theta can't be minus 180, 0, 180 or 360 or any multiples with 180 going either way. So we've got dots there again as well. Now what do I mean by theta can't be those? Well, when theta is, say, 0 and you try and calculate cot theta or cosec theta, you just get an error. It's undefined and you can't do it. So if you go to graph y equals cot theta, say, you'll find that there'll be asymptotes every time theta is one of these. There'll be a vertical asymptote saying that the graph is not continuous there, which will make more sense once we graph these things. So let's get those down, and that's it for the notes for today.